Hello and welcome. Today we're going to be looking at linear inequality word problems. As always, we're going to be looking at 5 questions, and then we're going to be explaining the intricacies of this topic through each of these questions to help you ace the SAT math portion. Of course, this topic is part of the heart of algebra, as all of our topics have been so far. It is the first subgroup in the SAT math portion. And if you like these videos, please be sure to like and subscribe. With that, let's get started. Question number 1 is, a study by a group of cardiologists determined that maximum heart rate in humans, a parameter used as a basis for prescribing exercise programs, depends on age. Maximal heart rate is around 201 beats per minute, BPM, for a 10-year-old and decreases at a constant rate of 7 BPM every 10 years. Which of the following inequalities best describes the ages A for which maximum heart rate is less than 180 BPM? Well, let's see what we can do here. Well, we start at 201 beats per minute for a 10-year-old. 101 beats per minute for a 10-year-old. Now, since we decrease by 7 BPM every 10 years, that means that we must have started higher. We must have started at 208 BPM at first. We started at 208 BPM, and then since we're losing 7 BPM every 10 years, we're losing 0.7 BPM every year. So we are losing, so basically, we can write this inequality as 208 minus 0.7a, and that is our heart rate after a certain number of years, a certain age. So this maximal heart rate, which is what this is supposed to be less than 100 BPM. So it's going to be less than 100 BPM. And when this inequality is true, so when ages are going up and higher, then this inequality is going to be true, and the maximal heart rate is going to be less than 180 BPM. So this matches up with our answer choice A right here. So that is our answer. And let's move on to the next question. All right, question number 2, here it is. There are currently around 2.4 million square miles of tropical rainforest. Most experts agree that around 125 square miles of tropical rainforest are being lost per day. If this rate of depletion continues, which of the following inequalities best describes the number of years from now, y, when the rainforest will be depleted to 2 million square miles or less? Well, so they're telling us that 1 year is 265 days. Obviously now you can get out your calculator and we can start doing this question. So we have 2.4 million, right? So so that's 2.4 million square miles. And every year we're losing 125 square miles per day. You pull out your calculator, right? This calculator active, as you can see up here by that icon. 125 times 265, and we're losing 45,625 square miles every year. So that's going to be times y. And so we're losing that much each year. So after y years, this is going to be depleted to 2 million square miles or less. So it's going to be equal to or less than. So less than or equal to. So 2.4 million minus 45,625y is the current, or is the amount of tropical rainforest left after y years, and this is going to be less than or equal to 2 million for the times that are being asked for in the question. This matches up with answer choice A, and that is our answer. Let's keep going. Question number 3, here it is. Fernanda is driving 240 miles from Charlotte, North Carolina to Atlanta, Georgia. She's planning to drive straight through except for 1 hour of time during which she will stop to refuel and eat lunch. Fernanda drives an average speed faster than 45 miles per hour, and if t represents the total number of hours, including driving and stopping, of Fernanda's trip, which of the following inequalities best models the situation described above? So if t is the total hours, then, well, we can do t minus 1 as the driving hours, since she's stopping for 1 hour. So driving hours. And since Fernanda drives at least 45 miles an hour, or faster than 45 miles an hour, the amount of distance she travels in that t minus 1 driving hours is going to be 45 times t minus 1. So that's the number of miles. And since she's driving faster than 45 miles per hour, then this is going to be the bottom end. This is going to be the least. So it's going to be less than the actual amount of miles she drove. And the actual amount of miles she drove in that t minus 1 hours was 240 miles total. So 45 times the t minus 1 is going to be less than the 240 miles, which is answer choice D, and that is our answer. Let's keep going. Question number 4, here it is. An audiologist is testing a patient to determine the softest sound of a specific frequency that the patient reports hearing. She begins with a 10 decibel dB sound for trial 1 and then increases the volume by 2 decibels for each trial after that. If the patient can only hear sounds of that frequency that have a volume louder than 26 decibels, and T represents the trial numbers that the patient can hear, which of the following inequalities best models the situation described above? Well, she has 10 decibels to start with, and then you're adding 2 for each additional trial. So we can say that's going to be 2t. But for trial 1, we start at 10. So we're going to make this t minus 1. And then trial 2, we would have 10 plus 2, which is 12. And then trial 3, we would have 14, and on and on. And this is going to be the sound at a certain number of trials. And we're trying to determine when this is louder, so greater than 26. And let's see, the patient can only hear sounds of that frequency that have a volume louder than 26 decibels, not equal to 26 decibels, which means that our answer is going to be answer choice D right here. So we are done with that question. Move on to the last question of this set. Here it is. Joanne and Richard volunteer at a hospital. Joanne volunteers 4 hours more per week than Richard does. In a given week, they do not volunteer for more than a combined total of 16 hours. If X is the number of hours that Richard volunteers, which inequality best models the situation? Let's see what we can do about this. Well, Joanne volunteers for 4 hours more per week than Richard does. So we can define, say, J, number of hours Joanne volunteers. That's going to be X, number of hours Richard volunteers, plus 4. And then the total is going to be J plus X. And this is going to be, so they don't volunteer for more than 16 hours combined. This is going to be less than or equal to 16. And then we plug this in here to get that X plus 4 plus another X is less than or equal to 16. So 2x plus 4 is less than or equal to 16. And that looks to be answer choice B. And that's our answer. And we are done with this. Whoops, we are done with this set. All right. So as you can see here, these linear inequality word problems, they're just going to give you these words. You turn them into inequalities, and then you just use the basic algebra skills we already know to solve them, to simplify them, right? There's nothing new here. It's just an application of our algebra skills and our application of our ability to make equations and inequalities out of these words. That is it for this time. I'll see you next time when we look at the next topic in the heart of algebra. Until next time, I'll see you later.